Just letting you know why it's only 3 days, if you care or not. There's a lot more to probability that we could do, but this is the 3 main things you'll see on the regions. So I don't want to waste your time, all right, doing all this extra stuff when I could save days to review when we get back from break. So these 3 days are the ones that show up on the reasons exam. All right, so that's why. Is there more we could do? Oh yeah, a ton more we could do, but not interested in it. It's not going to be on the regions. Not in your packet, but I got a couple questions for people. Hopefully you remember your numbers. This is an independent, dependent question. So I got a card, select from a deck, and I keep it back in the deck. Then I draw a second card. So me drawing those 2 cards, independent of each other or dependent on each other. I take a card from the deck, and then I keep it back in there. Then I select a second card from Friday. Dependent or independent of each other? Do the outcomes change based on what I did the first time? Woo! 4 in the house. Independent. Great job. Same number of cards. First pick, second pick. Didn't change. First pick did not affect the number of outcomes in the second one. All right, I got Andrea. She's what?
Doesn't it though? Because you're taking 1 less.
And kept in.
Kept in? Oh, I thought you mean kept.
No, kept in the deck. Kept in the deck. Yep, kept in the deck. All right, how about Andrea here? She selects a shirt from her closet to wear on Monday and then a different shirt to wear on Tuesday. Independent or dependent, picking those 2 shirts?
Dependent.
Or dependent? Why?
Because you're taking one out and then getting a different one.
Let's say she's got 10 to choose from on Monday. She wears one of them. How many does she have to choose from on Tuesday?
9.
Because it's a different one, right? Different one. All right, so that's why they're dependent. All right, here's the deal today. We're going to read this problem, and I'm going to ask you if they're independent or dependent, and we're not going to be too sure. So what we're going to have to do is run a test on it. If it passes the test, it's independent. If it fails the test, it's dependent. Take a look at example number 1. All right, Josh is late to school. I guess the probability is 30%, 0.3. And being late for the bus, 0.9. Is Josh being late independent or dependent of him missing the bus? I don't know, we could have an argument back and forth, right? You missed the bus, of course you're going to be late. Well, maybe he was late for another reason. Right? Maybe he got a ride to school that day. Traffic was bad. I'm sure you guys could relate, right? So how are we going to figure out if these are independent or dependent of each other? We're going to run a test and see if it passes or not. We're going to run a test. Everyone go to the front of your packet where you got all your formulas for me. Here we go, number 4. Number 4, if A and B are independent, and this is also in your notes, so don't worry. We're going to have to run a test. Ready for the test? When we calculate the probability of A given B, we know how to find that. We got a formula for it. Yeah, we do. When we calculate the probability of A given B, that probability should be the exact same as just the probability of A all by itself. If they're independent. That's the test we need to run right now. Is this probability the same as this one? If they are, independent. If it fails, dependent. Okay, so that's the test we need to run right now on Josh being late to school. All good? Let's do it. Let's see if it passes the test or not. So here's the test. We need to find the probability of Josh. What do you want Josh being late to school? Let's pick a letter so we're all on the same page. L for late. Yeah, great. The probability of him being late, given he missed the bus. What do you want that to be? B, you got it. Is that probability the same as the probability of, what do we need to check? If it's the probability, same as the probability of, thank you, good. You guys are transferring over A to B to L to B, good. Of him, I almost put an A, yep. Of him being late.
Wait, but don't you have an?
If this is true, they're independent. If it's false, it's dependent. All right, help me find the probabilities then. Okay, help me find these probabilities.
Wait, so why are you finding the given if it says and?
What are we talking about?
Like, I mean, I get that you need the equation to figure out if it's independent or dependent.
Yep.
So is that separate from like actually solving it?
What? There's nothing to solve.
Oh, okay.
There's no number here, Libby. I need.
Mm-hmm.
It's either independent or dependent. That's my final answer.
Okay.
It's not like 0.6 is going to be my final answer.
Okay.
It's either are they independent or are they dependent. Okay. All right, here you go. I think I've given you some info here. Probability of being late given the buses. He missed the bus. Guys, read the question here. I think I already gave it to you. You don't even need to do any calculating. Everyone see it? Probability of Josh being late given that he missed the bus is 0.9. 0.9. It's already there. We don't have to do any calculations here. Is everyone, we're reading the same thing, right? Yeah. Josh being late, given that he missed the bus, is 0.9. All good? Sarah, you good back there? Yeah. Or either one of you? What's the probability he's late? 0.3. Pass or fail here? Fail. Therefore, these two are? Yeah, it's probably the reason he's late is because he missed the darn bus. So they're dependent. Yeah, that's about as easy as it's going to get there, kid. Questions from you guys? All right. Now, there is a second way we could test if it's independent or not, and I'm going to give you both. And then what I want you guys to do is, you know what? I'm a little bit more comfortable doing it this way, and I'm going to keep continuing doing that way. What's your deal, Nora?
This was just the last question. Why was there X the 0.3?
Because it failed.
Oh, that was just okay. No.
That's just my
Okay.
Good question. Good question. Hey, what do you think I'm going to put if it passes? Check mark. Not a thumbs up. No, a check mark. Yep. What?
So there should be no calculations at all.
No. Sarah, I just happened to give you that probability. You might have to calculate it on your own if I don't give it to you. And then I do there we go. See what we're rolling here. Correct. And I could tell you, Sarah, this will be the last time I give it to you. All right, you're going to have to do some work on your own. All good? All right, next up. Oh, Kim having a little pizza for lunch on a Wednesday, like we care. It's Wednesday. It's going to be 0.4 probability of her having pizza for dinner. Ooh, 2. Ooh, going double dipping. 0.3. And then having pizza for both lunch and dinner. We've all been there. 0.05. Are they independent or not? Having pizza for lunch and having pizza for dinner. All right, so go back to your formula sheet right now, please. Go back to your formula sheet. This was test option number 1 to test if it's independent or not. See if it passes or fails. I'm going to give you a second test right now, and before you leave, hey, I prefer this one over this one, and you go with it. All right. Here's the second test you can do. Here's the second test. The probability of a little symbol, and B is the same as the probability of A times probability of B. And I know many of you are going to be like, wait a second, that's one of our formulas. You're right, because we use that formula when 2 events are independent. Okay? So that's how we're going to test. All right, that's our second test we could use. A and B, same probability if I multiply them. And I am going to force you to use that option here. Okay? So here's what we're going to test. I don't know if you want to write the word test, whatever. Probability, what do you want? L for lunch, D for dinner? Everyone all right? Okay. Pizza for lunch and dinner should be equal to probability of what? Oh, I don't want any numbers yet. Probability of lunch times probability of dinner. And please, guys, I can't stress this enough. You're doing a check. Does the left and the right side equal? All right, this is going back to what Libby just asked. I don't want a 0.6 answer here. Does the left equal the right when you calculate them? Lunch and dinner. What did I give you? Lunch and dinner. Point. Read it. Lunch and dinner. What's the probability she has pizza for lunch and dinner? 0.05. Is that the same as multiplying chances she had pizza for lunch? 0.4 times dinner? 0.3. You're checking. That's what you're doing. You're not calculating anything here for me. You're checking. Does the left equal the right? Does 0.05 equal, what'd you get here? 0.4 times 0.3? 0.12? Did they equal each other? No? So what does that mean then? Eating lunch, pizza for lunch, and eating pizza for dinner? Dependent on each other. Yes, dependent. And don't worry, you'll get an independent every once in a while here soon. So 2 different ways I could check. We're going to do 2 problems in a row now, and we're going to do both ways. And then at the end, we're going to say, all right, which way do you like the best? Alexa.
We're never gonna have like not enough information.
No, that's never going to be the issue. No, never. And also, we shouldn't be selecting Josh needs to wake up earlier. Okay? We shouldn't need that. Okay? It's going to be, anything I give you is going to be independent or dependent. Enough information. Let's take a quick breath. Ready to go. All right, now I got you a table. Get me some values off of. Sorry, and then again, Sarah, here you go. You got to work for it now. All right, you got to work. I'm not going to give anything to you. Is being over 14 years old and over 5 feet tall independent or dependent on each other? This is not your opinion, by the way. All right, this is not your opinion. Let's figure it out mathematically. Using option 1. If you go back, I want to use this one. I want to see if this is true or false now. Probability of A given B, is it the same as the probability of A? That's the one I want to use right now when I say option 1. All right, you guys are going to have to help me out using some notation here. So the probability of, what do you want me to do for over 14? Anybody? Can I use the number 14? I don't. No, you don't like that, Sarah? Oh, but then the other one's over. Like, it's got to make some sense to.
Why here?
The person is over 14 years old. What letter? Y for years? Okay, fine. Probability of Y given, what do you want for a person who's over 5 feet tall? F for feet? Okay, got it. Whatever that probability is, should be equal to what probability if they happen to be independent? Look back.
Why? Just why?
Guys, let's stop yelling at each other here and look back at the formula, right? Probability of Y given F should be the exact same probability as Y, okay? All right, here's this is why these 3 days are so important. You're You're going to get these two probabilities from a table that we worked with on Thursday and Friday. This isn't anything new I'm going to show you. Probability of over 14 given they're over 5 feet. First of all, should this be out of 100? No. What do you already know? They're over 5 feet. So I'm only looking at the people who are over 5 feet, which is how many of them? 67 total that are over 5 feet. How many of them are over 14? What's the problem? We're already given that they're over 5 feet. 67 of them. So this is the only place I'm looking right here. Out of those 67, how many are over 14? 58 out of 67, right?
Okay, yeah.
I'm not going out of 100 because I gave you that they're already over 5 feet. Everyone's good. Is that the same probability as, all right, just the person is over 14 years old? Oh, well, we got to find that probability. What's the probability on this table that the person's over 14? Over 14. There's 70 of them over 100.
You just do. Oh wait, no.
Now, I have no idea looking at those fractions if they're equal or not. What's a good idea to see if they are equal? Simplify them, see what the decimals equal to. So, yep, grab your calculating devices. I know the right side's 0.7. 58 out of 67. Point. What'd you end up? 58 out of 67? What'd you get?
0.86. Yeah.
Okay, 0.86. It's not 0.7, right? Right? It's not 0.7. That's what I really care about. So whether I say 0.86, 0.87. So what happened? It failed. So we should be dependent. All right, maybe you're not feeling that option. Maybe you're not. Maybe you like our second option I had just given you, which is probability of over 14 and over 5 should be equal to what? If they are independent. Look back at option 2. That probability should be the same as the probability of. So y times f. If you like that one better, let's use it. Okay, turn this over to you now. What's the probability of y and f now? Use your table. Y and f both happening. Over 5 feet, over 14.
Is it 58?
Nice, nice. I like the numbers. 58 out of. Right there, right? Over 14, over 5. Nice. Equals probability of over 14. 70 out of 100 times, what do we got? Over 5 feet? 60 out of, still 100.
Oh.
Okay, let's see if they're equal. Well, I think we know they're not because of the previous option, but I just want to make sure we can check it. I know that's going to be 0.58 right here. Not too sure what this is going to be on the other side. Point about what? All right, that's fine. As long as I see they're not equal. No?
No, yeah, I didn't realize you already times them.
Start getting a feel. We got one more where we're going to do both options. Start getting a feel of which one is in your wheelhouse. Anything you want to ask? I got one more. Now it's a Venn diagram, as you can see. And yep, we're going back to our good old mustard yogurt.
Yeah.
All right, pretty simple question. Mustard, yogurt, independent or not? Okay, mustard, yogurt, independent or not? All right, so option one is the given one. This given this. So is the probability of, what do you want, yogurt? Y, F?
Mustard.
Y,
And
frozen
given
yogurt?
Y.
Yeah.
Y, fine. Yogurt. Probability of yogurt given mustard. What should that be equal to if they are independent? This is option one. Probability of
Yogurt.
yogurt. They should have the same probability. Molly!
Does it matter if you said probability of mustard given yogurt?
Yes, but you better be equal to the probability of mustard then.
Yeah. But
See
like,
it?
you could do either.
No, you could do it either way. Just make sure it's equal to the correct thing.
Okay.
See what I mean?
Yeah.
Okay. Yes, Molly just asked. You could do probability of mustard given yogurt, but this better be mustard over here. Yep. All right, you ready to check? Ooh, how are we going to find this one, given the Venn diagram? This was day one.
Add them all
It's
up.
given mustard already.
Yeah.
I'm only choosing from the people who like mustard.
Wait.
Right? You know they like mustard. Given they like mustard. How many of them in the Venn diagram like mustard? Everyone over 50, not 22. 22 are the ones that only like mustard, plus the 33 that like both. All right, out of those 55, how many like yogurt as well?
33.
33. I'm not even touching the 87 because it's not even part of that 55 group. 33, not 37. Questions? Go ahead.
I don't really understand the given, like what it means.
It's already happened. So instead of ready, Libby, instead of out of everybody, I already know this person likes mustard. So the only people I know up here that like mustard are 55 of them. It changes your number of outcomes. Okay? Instead of out of 200, now it's a lot less. 200's everybody. Only mustard, though, is 55. Good? Now watch how it changes. What's the probability they like yogurt?
87 is 2. Well, do you include the 33?
Oh,
87 plus 30.
yeah, right? Because 87 only like yogurt, but there's some that like both, and that's yogurt included. So it's not going to be just 87. It's going to be 120. Now it's out of
200.
everybody. Everybody. 200. Oh, what do we got here? Oh, look what we got. What do you have? 0.6?
Oh my god, they're equal.
0.6? 0.6?
There is.
Yeah. So what are we saying here? You liking mustard has no effect on you liking frozen yogurt. How about that, Tomer, huh? You a big mustard guy? No, not at all? You don't have to put it on anything.
No,
Have you ever had it before?
I have
Okay. Nothing.
no,
Hot dog.
no,
Ham sandwich.
no.
Ooh.
Ew.
Yeah, no,
Ham
Yeah.
sandwich is
Yeah.
already gross.
Mayo and mustard.
I guess I
Wait,
don't
hate
know.
Mustard on least the ham
I would
sandwich.
never eat mayo. I hate mayo.
Why would you?
Just a little bit, because some of them get a little too spicy, some of the mustards. A little too spicy for me. All right, moving on. Option 2, so we can get through this. The other option I could have checked to see if they're independent was seeing if the probability of
Y
and M, is that the same probability as
Y.
yogurt times mustard by itself? Are those the same? We know the answer is going to be yes, but let's see the fractions that make it a yes. This is just good review too, finding this stuff using a Venn diagram. All right, kids, what do you think? Yogurt and mustard. Probability.
87, 72.
But it's and yogurt and mustard together.
Would it be 33 over
33 over 200. Is that equal to, here we go, we've already done yogurt, right? 120 out of 200 times, what about the mustard peeps here? 55 out of 200 again. We should have some winners here, I believe. Looking good. What is that as a decimal? No, 0.66? No, 65, pretty close.
Wait, for, I don't know why I'm just looking at this, for option 2, on the first one that we did, you know how it's dependent?
Yep.
But what did they equal? Because I have.
0.58 and 0.47
Oh, okay.
as a decimal.
I was thinking of.
What do we have? What do we say it was? 0.6? One's not 165. No chance. No chance.
0.165.
Oh, all right. Not 1 point.
What is it?
All right, now we've done a lot of this now. You should hopefully maybe be at the point where you're like, you know what, I'm going to go with this option because I'm not going to never force you to do an option. Never. It's whatever you feel comfortable with now and just going with it. Okay, that's where we are. You got to go with it now. So, yep, we're going to do this last one here. I know it says harder. Don't get scared or start sweating profusely. You'll be fine. I could have easily eliminated it from the notes, but I got faith in you. No story either. No story.
No, I like this.
Here's A, here's B. Ooh, wait a second. Here's what? Ooh, whoa, okay, that's interesting. Are A and B independent or not? Class decision, quick. Which option do we want to try here?
Second one.
The first.
I'm hearing majority second. All right, so here we go. Is P probability of A and B equal to the probability of A times probability of B? This is why it's going to be a little tougher. We all know what A is, right? 0.6. We all know what B is, 0.5. I remember, this is a check. It's not an answer. It's a check. I gave you A or B. We're not plugging 0.8 here, kids. That's A or B. I need A and B.
Oh, do you do another equation?
0.8's not working for me here. Is there anything I have given you that has an or probability mixed in with an and?
Number 2.
Oh, so we're going to have to do like almost like a mini equation, huh? Watch. What's the one I gave you that involves or? Probability of A or B. That's gross. Yep. Probability of A or B was equal to what on your formula sheet there?
Probability of A plus probability of B minus probability of A and B.
Okay. That's how I'm going to get this value. Take a look. Take a look. That's how I'm going to get this value to plug in there. Well, now that's why I'm doing them with you. All right, that's why. And we got 2 days of review. I can't spoon feed you the entire time here. I got to make you think on your toes. All right, A or B. What are we plugging in? 0.8. Everything's given to you here, guys. A, 0.6. B, minus. If you want to leave that, you can. You can just put an X in there. That's what you're trying to figure out, right? All right, how comfortable are we doing this?
Super.
Oh, yeah? What's first step?
Minus 0.6.
Oh, you could. I'd probably do something before that.
Add the 2 on that.
How about some like terms, huh?
Combine.
1.1
Yeah.
minus x.
Now.
Now minus 1.1 on each side. Negative 0.3 equals negative x.
You divide by negative
Yep, don't want to leave it like that.
x.
Divide by negative 1. X is, or the and is 0.3. There it is. So now I go back up. I plug in 0.3. And we test. And we test. And what do you find out? They are equal. Independent. Do not waste any time. Boom, flip it over. Let's roll. Have an option you're always going to use in your mind. Right up to the bell, please. Right up to the bell. And we get ready to get moving tomorrow. I just finished up the details of the test this morning. I'm not gonna grind away at you on Thursday. All right, basic stuff. Got to know your formulas. Got to be able to read a table, Venn diagram.